Hi students, in previous class I explained regarding the specific charge and properties of light, and now another important concept in that atomic structure in continuity, that is electromagnetic spectrum. So now if you observe this electromagnetic spectrum, what is meant by electromagnetic spectrum? See, as you know, we have different radiations, and those radiations which are having both electric and magnetic fields which are perpendicular to each other, they are what we call as electromagnetic radiations. And here the vertical component is nothing but electric field and horizontal component is magnetic field. And now here we have important electromagnetic radiations, and as you know the properties of light, that is frequency, energy, wave number and wavelength. So here what we are going to do means, if you arrange whatever the electromagnetic radiations that we are having in a specific order, and here I am going to arrange them in the increasing order of the wavelengths. See, for example, this is the way what we have to consider the arrangement. Means in that direction wavelength is going on increasing. So in that, the first one what we will get, that is cosmic rays with the shorter wavelengths, and after that we have gamma rays, X-rays, ultraviolet, visible light, infrared, and here we are having micro and radio. So like this we are having different electromagnetic radiations in increasing order of wavelength. So in this direction wavelength is going on increasing, and as you know this wavelength is inversely proportional to energy, frequency and wave number. So in the same direction, energy, frequency, wave number, they are going on decreasing like this. But if you observe the velocity of all these electromagnetic radiations, they remains same. Means all electromagnetic radiations, they are traveling with the same velocity, of course, which is equal to the velocity of light. So first you should know the sequence of these radiations and in which order we arranged. That is very, very important. So if you have this idea, the simple questions what we are expecting on this concept. So generally they will give 4 radiations, and among them we have to identify either increasing order of wavelength or decreasing order of wavelength. In a specific order they will give. So for that, see, for example, here we are having 4 important radiations what they have given as the options. For example, visible, and the second one is X-rays, and third one is gamma rays, and fourth one is micro. So these are the options. Now the question will be, which of the following we have highest wavelength? Very simple, if you remember that order, highest wavelength. So among all these, we are getting microwaves here. So definitely this is the electromagnetic radiations with highest wavelength among the given form. Like that, maximum energy or maximum frequency. So with respect to those properties, we can expect the question in any way. And now another model, increasing order or decreasing order. Suppose if you want to arrange these radiations in the increasing order of their wavelength. Increasing order of wavelength means first we get gamma rays. They are having minimum wavelength C, which is less than. After that we get X-rays, that is B, which is less than visible A, less than D. So like that we have to arrange those radiations in the increasing order of wavelength. In the same direction, energy, frequency and wave number, they are going on decreasing. So it's a very simple part if you remember that order and in which order we arrange those radiations. And another one, see suppose here, for example, another model what we can expect. Imagine there are X-rays whose wavelength will be lambda 1 and gamma rays whose wavelength will be lambda 2. What is the relation between lambda 1 and lambda 2? Relation means just they are going to give either lambda 1 is equal to lambda 2 or less than or greater than, that we have to observe. So as per the diagram, since we are having X-rays here and gamma rays here, in this direction wavelength is going on increasing. That means no doubt lambda 1 is greater than lambda 2. So like that simple questions we get on this electromagnetic spectrum. And another important point here, what we have to remember, if you observe the visible light, in visible light again we are having 7 colors. That is from violet to red, means violet, indigo, blue, green, yellow, orange and red. So like that we are having 7 colors in visible light. And here also from violet to red, what will happen to the wavelength? That will be increases. If wavelength is increasing, energy, frequency, wave number, they are going on decreasing. So like this, as far as the visible light concerned, from violet to red, wavelength is going on increasing. That indicates in visible light, violet color is having maximum energy, whereas red color is having minimum energy. Or violet is having minimum wavelength, whereas red color is having maximum wavelength. So that is enough regarding this electromagnetic spectrum, and be clear about that sequence and in which order with respect to the wavelength we arrange. That is the most important. So this is as far as the electromagnetic spectrum concerned in view of those objective examinations. Okay, right. Hi students, in previous class we observed regarding electromagnetic spectrum, and now next to that we have another important part, which is nothing but photoelectric effect. So now here, what is this photoelectric effect? Now imagine if you observe any metal surface like this. Imagine this is the metal surface, and as you know metals are having very low ionization energy. So if there is any incident light, say for example this is an incident light whose energy is E. So what happened? From that light, the electrons present on the surface of that, means the atoms present on the surface of that metal, definitely they are gaining certain amount of energy. So after that, there is a process of ejection of the electrons from this metal surface. Now that process of ejection of the metal surface by an incident light, that is what we call as photoelectric effect, and those electrons are what we call as photoelectrons. And now here the entire concept related to the photoelectric effect is in the diagram only. See how whenever if you are using energy like this, to remove that electron, definitely it requires certain energy. Means from this total energy what we are using, a part of energy was utilized to remove that electron. That is what we call as ionization energy or work function or threshold energy. Means minimum energy required to remove that electron. And the remaining energy present in that light is going to converting into kinetic energy of the ejected electron. So in that diagram there is complete information regarding photoelectric effect, and as per that, if you observe the mathematical representation for this to get an idea, the total energy E, that is nothing but the sum of the work function or threshold energy plus kinetic energy of the ejected electron. So that expression represents the magnitude of total energy what we utilize for that photoelectric effect. And now, as you know, according to quantum theory, that means since E equal to h nu, in properties also we observe. So as per this, total energy utilized, that is nothing but h nu, which is equal to threshold energy, which is also energy. But here, since that is the minimum energy required, so frequency is also minimum. That means this threshold energy can be considered as h nu naught plus kinetic energy of the ejected electron. So according to this, kinetic energy of the ejected electron, which is nothing but the total energy utilized minus, means the total energy what we utilize onto the surface of the metal minus energy utilized to remove that electron. So as per this, here it is nothing but h into nu minus nu naught. So this is the way how to find out the kinetic energy of ejected electron, where nu is frequency of incident light and nu naught is threshold frequency. So as per this, if you are using two different frequencies with different lights, then Ke1 by Ke2, that is nothing but nu1 minus nu naught by nu2 minus nu naught. So like this, if you know the ratios of the kinetic energies, we can find out nu naught, means threshold frequency of the metal, or directly we can find out the ratio of kinetic energies of those ejected electrons. So this is one part related to this photoelectric effect. And now, since the expression, that means energy equal to threshold energy plus kinetic energy, sometimes they are not giving frequencies. They are going to give the wavelengths of the incident light and the wavelength that required, means if you observe this formula, kinetic energy. So according to this, in terms of, means with respect to wavelength, kinetic energy, if you want to find out this, here it is nothing but nu is nothing but c by lambda, so hc by lambda. That means here it is hc by lambda, where lambda is the wavelength of utilized light, minus hcc by lambda naught. Lambda naught means threshold wavelength. So according to this, kinetic energy is nothing but hcc into 1 by lambda minus 1 by lambda naught. So if they mention the wavelengths, by using this formula you have to find out kinetic energy, and of course the units of wavelength what we are going to use, that depends upon the units of energy what they mention. Suppose if the units are in x, you have to convert wavelength into centimeters, and if the units are joules, you have to convert wavelength into meters. Already you know that conversion. So in this way, either with the help of frequencies or with the help of the wavelengths, we can find out the kinetic energy of the ejected electron. Now, based on this, a simple problem, that means, see for example, there is a metal, and whatever the energy that we utilize, means the light what we are using, that is around, for example, if it is 5.6 into 10 power minus 19, this is 5.6 into 10 power minus 19 joules. That is the total energy utilized. And after that, we observe the kinetic energy of the ejected electron. It is around 12. This kinetic energy, that will be 12 into 10 power minus 20 joules. Then what about the work function or the threshold energy of the metal? This is one model. So entire problem is in that diagram. Means the total energy what we are using, that is 5.6 into 10 power minus 19, and kinetic energy of the ejected electron is 12 into 10 power minus 20. So then what is this threshold energy? See that Here energy, that is 5.6 into 10 power minus 90 joules. And after that, kinetic energy, since that is 12 into 10 power minus 20, now I can write 1.2 into 10 power minus 19 joules. So therefore, work function we have to find out. So now, as per the relation, that is E equal to W plus KE, therefore, work function equal to E minus kinetic energy. So that indicates 5.6. Since 10 power minus 19 is common, so minus 1.2 into 10 power minus 19 joules. So that means here it is around 4.4 into 10 power minus 90 joules. That is the work function of that method. So like this, just if you understand the diagram, automatically the simple calculations what we are going to expect, they are very easy without any confusion. And now once again we will come to that process. See, as far as photoelectric effect concerned, since we are getting the electrons with different frequencies, so what will happen to the kinetic energy of the ejected electron if frequency of the light is increasing, or if the intensity of the light is going on increasing? So for that, here there are four important graphs. First one, the relation between the kinetic energy and the frequency. This is kinetic energy and it is frequency of the light what we are using. And once again I will give the diagram. So this is electron with the kinetic energy, and here we are using the light of frequency nu. Now, if that frequency is going on increasing, since light is composed of photon, we are increasing the frequency of the photon. But one photon is responsible to eject the one electron only. So thereby what happens? If you are increasing the frequency, energy of the photon is increasing. So thereby, where work function is constant, definitely the kinetic energy of the electron is going on increasing. Means here we will get the graph like this. See, if you observe this intersecting point, this is the minimum frequency what we require to remove that electron. So that is called threshold frequency. So like this, kinetic energy is going to depend upon frequency of the light what we are using. And similarly, for example, number of electrons. So what about the relation between number of electrons and the frequency? So this is number of electrons. Just now as I said, just we are increasing the frequency of the photon, not number of photons. So even though we are increasing the frequency of the photon, number of electrons ejected, they remains constant. So here we will get the graph in this way. So here two statements. Kinetic energy of the ejected electron is going to depend on frequency of the incident light. Whereas number of electrons ejected, they are independent on frequency of the light. So like that, in statements wise, we will get the questions. For that, you should remember the graphs. And next another one. Here, kinetic energy and intensity. What will happen to the kinetic energy of the ejected electron if intensity of the light is going on increasing? So here you should know what is meant by intensity. See, for example, this is the unit area. On unit area of metal surface, how many photons are falling? Imagine each dot represent one photon. So now there are 7 photons. So the intensity, that is nothing but 7. Suppose 10 photons, intensity is 10. So like that, if number of photons which are falling on unit area, that is what we call as intensity. Now, if intensity is increasing, number of photons were increasing, not frequency of the photon. So thereby, since number of photons are increasing, kinetic energy of the electron remains constant. No change in kinetic energy. And similarly, if you observe the number of electrons and intensity, here, just as I said, one photon is responsible to eject one electron. Now, if 2 photons are there, 2 electrons, 10 photons are there, 10 electrons. So like that, here the number of electrons are going on increasing. So in this way, 4 graphs and 4 statements, they are very, very important. So once again, kinetic energy is proportional to frequency of the incident light. Number of electrons are independent on frequency. Kinetic energy is independent on intensity of the light. And number of electrons are proportional to intensity of the light. So like that, statements wise, you have to remember these four graphs. Next, another one. See, if you are using the light with sufficient energy, then only we are going to observe photoelectric effect. So here there are three important relations. That means, first one, if incident energy means E, if it is greater than threshold energy, means utilized energy, whatever the light or the incident energy, if it is greater than utilized energy, so electron is going on escaping from that metal surface and its kinetic energy is greater than 0. So in this condition, no doubt kinetic energy of the electron means Ke, that is greater than 0. And next, another one, suppose if incident energy is equal to threshold energy. See, for example, here it is 2 electron volts. We are using the light of 2 electron volts. So then electron will be removed, but no chance of kinetic energy, because the entire energy was utilized just to remove the electron. So in this condition, kinetic energy of the electron becomes 0. And next, third condition, suppose if incident energy is less than threshold energy, here no chance of photoelectric effect. There is no photoelectric effect. So like this, the three relations you have to remember. So just if you have that fundamental formula in your mind, automatically you will get all these relations as the statements. And now here, if you observe this third condition, means main purpose of this photoelectric effect that was considered by Einstein to explain how the emission is taking place from normal bodies. So for that, here, if the incident energy is less than threshold energy, definitely that energy is going to absorb by the electron, but electron is not able to eject out. But instead of that, see, already it is present in an orbit or energy level whose energy is E1. Now we are providing insufficient energy. So then by observing that, instead of escaping out, it is going to excite to higher orbits where the energy is, let it be, E2. But in a short span, again it is going to de-excite like this from higher level to lower level. During this de-excitation, whatever the energy absorbed, that is going to release and propagating in the form of photons. So like this, in real bodies, the emission of radiation is due to de-excitation of the electron from higher level to lower level, and that is in the form of photons. But here, whatever the energy associating with this each photon, there is nothing but energy difference, delta E, which is equal to quantum as per quantum theory. So according to this delta E is nothing but E2 minus E1, which is equal to h nu. So like that he suggested how the emission is taking place in case of real bodies. So that is regarding the concept of photoelectric effect. And now here after this, if you recollect that quantum theory. So in a brief, in a simple statement, I am going to conclude that quantum theory, that means according to that quantum theory, the energy emitted from a black body, that is in the form of quantum. So now, if you observe this quantum theory, the mathematical expression that we are having, that is nothing but the energy associating with each quantum is directly proportional to the frequency of the vibrating particle in the black body. And as per that, E equal to h nu. And as you know, h is nothing but Planck's constant, and nu is nothing but c by lambda. So as for that, we can express E equal to hc by lambda. But in that quantum theory, another important postulate means whatever the quantum means energy, it is an integral multiple of each quantum. Means E equal to n into h nu, where n is nothing but number of quantum. The same concept we can apply for the Einstein concept also. How to find out number of photons? So here n is nothing but number of photons. According to this, number of photons equal to energy, total energy by energy of each photon. So in this way, here you have to remember the mathematical representation for quantum theory. So both photoelectric effect and quantum theory. Hi students, in previous class we observed that conceptual approach for photoelectric effect, and now I am going to explain three important models based on that photoelectric effect. See here, four metals, they have the work functions like that, and suppose if those four metals are irradiated with the light of frequency, that is 8.45 to 10 power 14 hertz, how many metals will shows the photoelectric effect? That means from how many metals we will get the photoelectrons. So here the condition what we have to remind to analyze this, if the energy of this incident light, if it is greater than the work functions or threshold energies, definitely in that situation those metals are going to exhibit photoelectric effect. So now already they mentioned the work functions in electron volts, but here they have mentioned the frequency. So first of all, we have to find out the energy of that incident radiation, that too in electron volts. So for that, here the given information, if you observe the solution, the given information nu equal to, that is 8.45 into 10 power 14 hertz. Now we have to convert this frequency into energy. So for that we have formula, that is E equal to h nu, where h is Planck's constant. So first we are going to calculate the energy in joules. So that means 6.625 into 10 power minus 34 joule second, that is h value, into frequency, that is 8.45 into 10 power 14. So now here on multiplication, here it is going to be 55.989 into 10 power minus 20 joules. So that is the energy of incident light. But they mentioned the work function in electron volts, and we calculated the energy in joules. So now in electron volts, what about the energy? Means, as you know that 1 electron volt equal to 1.602 into 10 power minus 19 coulombs. So thereby it is nothing but 55.989 into 10 power minus 20 by 1.602 into 10 power minus 19. So here it is around 3.4, or if you observe up to the second digit, it will be 9 electron volts. So that means this is the energy of incident light, whatever that we are using on the surface of the four metals. So now here energy is 3.49. Now observe the work functions. So here for photoelectric effect, the condition, that is here the work function, it should be less than incident energy. So for how many metals the work function is less than 3.49? That is A, B, C. Means for the first three metals, work function is less than 3.49, and whereas the fourth one, that is 5.6, means from D, if you want to remove the electron, we require a minimum energy of 5.6 electron volts. But here we are using only 3.49, so therefore number of metals which shows photoelectric effect. So here they are nothing but 3 metals. So what are those 3? That is A, B and C only. So like this, whenever if there is a model in this way, since work functions they are in electron volts and they are giving the frequency, sometimes they may give the energy also, but convert or compare the work functions and energies in the same units. Then if work function is less than incident energy, all those metals they are going to exhibit photoelectric effect. So this is one important model on photoelectric effect. Now the second example based on that photoelectric effect. See the question. When a metal was irradiated with the light of frequency 3.2 into 10 power 16 hertz, whatever the electrons that we are getting, the kinetic energy is twice as it did with the light of frequency 2 into 10 power 16. So then, what is the threshold frequency of the metal? Now just see, I am converting this total problem into a simple diagram. If you understand the diagram, it's very easy to solve that. See, imagine this is metal surface. Now, here we are using 2 different lights. See, for example, this is one light whose frequency is mu1. And we are using another light whose frequency is mu2. Now, for example, if this mu2 is 2 into 10 power 16 hertz, and now here we are getting the electron with kinetic energy, that is Ke2. Now onto the metal surface we are using another light whose frequency is nu1, that is 3.2 into 10 power 16 hertz, and here we are getting the electron whose kinetic energy is Ke1. But of course here, since the metal is same, nu0 remains constant. Now if you understand the question, the kinetic energy means Ke1 is twice that of Ke2. That is the meaning of that question. So if Ke1 equal to 2Ke2, then what is nu0? If Ke1 equal to 2Ke2, then here we have to find out nu0. That is the way how to analyze this problem. So now here we have to consider the 2 kinetic energies, that is Ke1 and Ke2. Already they mentioned the ratio, and here the formula what we have to use. Once again see the diagram, and if you understand this diagram, it's very easy to get that. Now I will give the solution. That means here, as per that, the data means kinetic energy, the relation what they mentioned, that is Ke1 equal to 2Ke2, and mu1, that is equal to 3.2 into 10 power 16 hertz, and mu2, that is 2 into 10 power 16 hertz. So here you have to find out nu0. Now the relation what we are having, that is Ke1 by Ke2. Already you know that formula, that is nu1 minus nu0 by nu2 minus nu0. This is what the formula we have to use here. Now already you know, means the ratio Ke1 by Ke2, that is equal to 2. That means 2 equal to nu1 minus nu0 by nu2 minus nu0. Now on cross multiplication, here we will get nu1 minus nu0 equal to 2 nu2 minus 2 nu0. So 2 nu2 minus 2 nu0. So according to this, if you bring that 2 nu0 here we'll get nu0 will be equal to nu1 towards that right hand side, that is 2 nu2 minus nu1. So thereby 2 into nu2, that means 2 into 2 into 10 power 16 minus nu1, that is 3.2 into 10 power 16. So it is nothing but 4 minus 3.2 into 10 power 16. 4 minus 3.2 means 0.8 into 10 power 16 or 8 into 10 power 15 hertz. So that is the threshold frequency of the metal. So now see this problem. First analyze the information what they have mentioned, and here the formula what you have to use, that is K1 by K2 equal to nu1 minus nu0 by nu2 minus nu0. So on simplification we are getting threshold frequency of the metal. So this is another important model based on photoelectric effect, and we will go for third one. Now see that third one. If a metal is irradiated with the light of frequency, that is C to 10 power 19 second inverse or hertz, electron is emitted with kinetic energy of 6.625 into 10 power minus 15 joules. Then what is the threshold frequency of the metal? Means here also I am giving the diagram for this problem. So imagine this is the metal surface, and here we are using a light of frequency, that is 3 into 10 power 19 second inverse, and there we are getting electron whose kinetic energy, that is equal to 6.625 into 10 power minus 15 joules. That is the experiment. If it is like that, what about threshold frequency of the metal? So like that, try to convert any problem into a simple diagram as per your convenience. Definitely it is very easy to understand that. So now the mentioned frequency and kinetic energy of electron, and we have to find out nu0. Already we have one formula, that is kinetic energy equal to h into nu minus nu0. So first we will go for nu minus nu0. So therefore nu minus nu0, that equal to kinetic energy by h. So now substitute the values. 6.625 into 10 power minus 15 by h value 6.625 into 10 power minus 34 joule second. And now here it will be, it is going to be cancelled, and finally we will get 10 power 19, means that will be equal to 1 into 10 power 19. That is nu minus nu0. But here we require nu0, so therefore nu0 equal to nu minus 1 into 10 power 19. Now what is nu? That is 3 into 10 power 19 minus 1 into 10 power 19. That means 2 into 10 power 19 second inverse. So that is the threshold frequency of the given metal. So like this, we will expect the models related to photoelectric effect. But in this concept, if there is any question, try to convert that question into that diagram. So then, as per the diagram, you will get everything, and I hope you will be in a position to solve any problem related to the photoelectric effect by having this information with you. Okay, thank you.